Next, we're going to do question 3. Question 3 was a previous lecture test question. There's a context given in the question. It may be a bit long, but I guess for most of the time when you are reading context like this, they're really trying to tell you a story. And from the story, you should be able to get a lot of the hints on how you could go about addressing what is required by the question. So anyway, this particular story is really about epoxidation or some form of oxidation kind of reaction. And then they are trying to tell you that there's this particular catalyst known as DIPT. You don't really need to know exactly like what it does, but all you need to know is that it delivers the oxygen. In this case, from the top. If you want to deliver the oxygen from the top, then you need to use the plus version. If you want to deliver the oxygen from the bottom, you need to use the minus version. Okay, and then they kind of tell you that okay, there's this particular plane, and then this is how you should place your R1, R2, R3, and then your CH2OH group. And then in this particular question, you were given S. Okay, it's able to react with DIPT with an unknown configurations. So that means that it's either plus or minus. So don't over read the question. So you're just your answer is supposed to be just plus or minus. Uh, and you notice that the product has the oxygen pointing inside. So all you need to do is just to fit S into the above cartoon. Okay, so if you actually try to fit S in, you realize that over here your R3 your R3 is actually your H. So this is your R3. So the H here is actually your R3. Okay, and then your R1 is this ethyl group, and then your methyl group is R2. Okay, and that will mean that in order to deliver the oxygen from the bottom, right, you have to use, if you just use this particular model, because you need to do a bit of flip, you need to flip S to fit to this particular model. Then you actually have to use plus DIPT. Okay, so when we mark the scripts, some students put minus because they just look at this and then they just try to fit everything in, and then they realize, oh, come from the bottom, so it must be minus. So you have to be really, really careful when you're dealing with this kind of question. Okay. So next, very quickly, we're going to go into part B1. When epoxides are subjected to sodium hydroxide, the epoxide ring will open and the diol will be obtained as shown below. So this is similar to a epoxide. It's a ring opening reaction. It's some form of SN2 if you really look at it. So now we want to look at the context. The context is actually sodium hydroxide solution. Okay, sodium hydroxide solution here. So if we have sodium hydroxide solution here, that means that I'm going to have OH minus in the presence of H2O. Okay, so the epoxide reaction can be simply envisioned by you having a nucleophile on one end, perform a nucleophilic attack, and then the ring opens. Okay, and then your intermediate will look something like that with O minus. Okay, and then you have your H2O here, which will then allow the lone pair of electrons to undergo acid base with the H2O and then regenerate the OH minus. So this is something that you might want to expect that how the ring opening takes place. And the particular driving force for this ring opening is really in the relief of the ring strain, because you realize that for a three-membered ring, the OCC bond angle is being forced to take on close to 60 degrees geometry, where ideally it should be close to 109.5. Okay, so over here they mentioned that when epoxide T, so where's epoxide T? Okay, so epoxide T is actually over here. So when epoxide T is subjected to sodium hydroxide solution, two products are possible. One of the products, W, has RS configuration at C1 and C2. So now they ask you to draw the structure of W. Well, I mean, you can simply just follow this narrative. You have R and S configuration at C1 and C2. I don't think this is a very major issues, but we will try to solve part one and part two together. Okay, we notice that a lot of you, when you draw your mechanism, you simply just use T in the form of T shown in the diagram. You could actually try to draw T to your advantage so that you are able to track the change in configuration in an easier fashion. So in this case, my suggestion is you might want to draw T by showing the relevant stereochemical projection at C1 and C2. Okay, so what I'm trying to say is I'm going to draw one here. So I can draw the epoxide out first. Okay, so this is C1 and C2. Okay, and then once I drew this out, right? Um, okay, maybe it might be easier if I put uh, 2 on the other side because I'm kind of like flipping it over. Okay, then you will notice that the H is now projecting towards you at C2, and then the ethyl group is projecting away from you. Okay, and then for C1, the methyl group is projecting away from you, and then your CH2OH group is projecting towards you. Now, did you realize that by drawing it this way, it's kind of similar to the cyclic bromonium cation, which you have gone through for activity 5. And this actually allows you to track the stereochemistry relatively more easily. Okay, so in this case, when I have my hydroxide coming in, potentially it can approach from both ways. So maybe I can try to draw it approaching from carbon 2 first, and then the ring opens. Okay, so when it approaches from carbon 2, this is what I'm going to get. So I'm going to change the color. Okay, so the OH will be like this, and then ring open, I'll have an O minus here, and then projecting in, projecting towards you, OH, and then projecting away from you, and then the H like this. Yeah. Okay, and then you can continue to draw by showing the deprotonation of water. Okay, and then to get the product. The next thing you could do is there's another possibility. I'm going to use another color. Okay, where the OH minus can approach from carbon 1, and then we'll ring open the other side. Okay, so over here, because the ring opens the other side, O minus is now over here, the left hand side, and then now the OH, and then the group projecting away, projecting towards you, OH, projecting in, and then the H is here. And then again, we can show the acid base neutralization product by showing the deprotonation of water if you wished. Okay, yep, and then you realize that this is actually W. This is actually W with the relevant RS configuration. Okay, so the key to answer B2, right, is that you really need to showcase the mechanism for both. The reason why we need to do that is that we want to be systematic in the way we approach working on the problem. Yeah, so we attack one side, this is what I get, and then we attack carbon number 1, and this is what I get. Yeah, so this is the kind of strategy that we really want to impart already. Want you guys to pay attention to do it systematically rather than just whack one and then after that try to get one answer from there. And then if it happens to be the answer, you're happy about it. If it's not the answer, then you'll be marked wrong. And sometimes you may not realize why you get it wrong. Is it because by chance or you know? So I think the best approach to do this kind of question is really to do it in a systematic manner. Okay, then of course the question is suggest if W is the major product. So briefly explain why. Right? So you realize that for this kind of epoxide ring opening, right? I think it's kind of written somewhere. Okay, it might be in your notes or not, but okay. This is a SN2 light attack. This is a very big clue that you might want to take note of. That's why I put a double star, in fact. SN2 light attack, right, here implies that the rear must be relatively unhindered. So if you compare between carbon number 1 and carbon number 2, right, carbon number 1 is some sort of a tertiary center, if you want to call it, and then carbon number 2 is like a secondary center. So in order to get W, carbon number 1 needs to be attacked, which is relatively bulky or bulkier as compared to carbon number 2. So because it is SN2-like, so you would expect this particular route to take place in a more prominent way. So carbon number 2 will be preferred to be attacked. So therefore, the answer to this question, which is part 3, is that I would expect W not to be the major product. And the reason is because if I want the reaction to occur in an SN2-like fashion, the nucleophile must approach the carbon from the relatively, or rather approach the relatively unhindered carbon. And in this case, C2 is more unhindered than C1. Okay, or you can say that C2 is secondary, C1 is tertiary. Okay, so whatever you mention, as long as you give the ingredient of the fact that you are aware of the steric bulkiness of the group, then I think you will get the credit. Okay, and then of course for part 4 is just a pattern recognition kind of question. They ask you to suggest a suitable starting material for the other diastereomer T, and then keeping the configuration the same. I think I don't think most of you have any issues with it. Okay, so I don't think I'm going to spend time debriefing this.